Measuring the frequency of a sound using a cathode ray oscilloscope. If we attach a microphone to a cathode ray oscilloscope and the microphone picks up a pure note, it would give a trace something like this, a sine wave. There are two important dials on the oscilloscope. One is the Y gain, which tells us how many volts of input are needed to rise one square on the vertical axis. In this case, the Y gain is 0.5 volts per centimeter, meaning this trace has a peak voltage of 0.5, 1, 1.5 volts. However, to find the frequency of a sound, we don't need to consider the Y gain further. What is important is the time base. This one is set to 5 milliseconds per centimeter, meaning that the line takes 5 milliseconds to travel 1 centimeter or 1 square. So for example with this wave, the time period would be from, for instance, here to here, a distance of 1, 2, 3, 4, 5, 6, 7, 8 centimeters. So the time period is equal to 8 centimeters multiplied by the time base setting of 5 milliseconds per centimeter, giving 40 milliseconds time period. Frequency is given by 1 over time period, which is 1 over 40 milliseconds or 0.04 seconds, giving a frequency of this sound of 25 Hz. This is a very low note. Here we have a time base setting of 1 millisecond per centimeter, and this wave has a period from, for instance, here to here, covering 1, 2, 3, 4 centimeters. So the time period for this wave is 4 centimeters multiplied by 1 millisecond per centimeter, giving 4 milliseconds. The frequency is 1 over the time period at 250 Hz. Here again a time base of 1 millisecond per centimeter, and the period now we could take from here to here, which is 2, 4, 6, 8, 10, 12 centimeters, giving a period of 12 multiplied by 1 millisecond per centimeter, or 12 milliseconds. So the frequency 1 over 0.012 seconds, 83 Hz. Now the time base is 2 milliseconds per centimeter, and the period of 2, 4, 6, 8 centimeters multiplied by 2 milliseconds per centimeter, giving a period of 16 milliseconds. Frequency is 1 over time period, 1 over 0.016 or 62.5 Hz. A time base of 5 milliseconds per centimeter, and a period from here to here, 1, 2, 3, 4 centimeters, giving a period of 4 centimeters times 5 milliseconds per centimeter, or 20 milliseconds. Frequency is 1 over time period, which is 50 Hz. Here the time base is 2 milliseconds per centimeter, and the trace 1, 2, 3, 4 centimeters time period. So the time period is 4 times 2 milliseconds per centimeter, or 8 milliseconds, giving a frequency of 1 over 0.008, 125 Hz. If there are a large number of waves on the screen, it would be more accurate to find the time taken for several waves and then divide by the number of waves. For example, we could take the trace from here to here, maybe, which covers 1, 2, 3 complete waves. Finally, this trace has a time base setting of 2 milliseconds per centimeter, and the time period from here to here is 2, 4, 6, 8, 10, 12 centimeters, giving a time period of 12 centimeters times 2 milliseconds per centimeter, or 24 milliseconds. Frequency is 1 over time period, which is 42 Hz.